Have you noticed that upgrading your tech is suddenly feeling a lot more expensive lately?
Oh, absolutely. I mean, people are definitely starting to feel that squeeze in their wallets.
Right. Like Apple just recently bumped the entry-level MacBook from $599 up to $699. And, they didn't make the screen any better. They didn't upgrade the processor or anything.
Yeah, it's the exact same machine, basically.
Exactly. You're paying more because, believe it or not, a massive AI data center in the middle of the desert is currently buying up all the computer memory on Earth.
It's crazy to think about, but that is the unseen reality of the hardware market right now. We are so used to the idea of consumer tech getting, faster and cheaper every year.
Right. Moore's Law and all that.
Yeah, exactly. But we're entering this phase where the extreme physical demands of artificial intelligence are creating this invisible tax on everyday devices.
Okay, let's unpack this, because the mission for today's analysis is to figure out the actual mechanics of that tax.
Which is so important because, AI is constantly marketed to us as pure software, right?
Yeah, like it's just a chatbot or some weightless cloud service,
Right. But its first truly broad consumer price shock is arriving through the physical hardware inside the phones and laptops you already own.
which is wild. So for today's analysis, we need to look at whether this is just like a temporary supply chain squeeze or if we're facing a permanent new layer of inflation in the tech world entirely.
And to really get to the bottom of this, we have to look at the physical architecture of these AI systems.
Right, because to understand the price tag on a basic laptop, we first have to understand the anatomy of a computer, right?
Yeah, absolutely. Because everyone who follows this space knows all about the GPU shortage. I mean, NVIDIA's chips get all the headlines.
Oh, for sure. But the actual bottleneck right now, the thing causing that MacBook price hike is memory.
Yes. And to understand why memory is suddenly the choke point, we have to look at the mechanical difference between a compute-bound task and a memory-bound task.
Okay, so let's break that down for a second. If we think about the three jobs of a computer, right? You have your logic chips doing the calculating. The storage is basically the filing cabinet for later. And the memory, the RAM, is the desk where you're actively working.
That's a great way to put it, and that distinction is everything. Traditional tasks like rendering a video or calculating a complex spreadsheet, those are compute-bound.
So the processor is the limiting factor there.
Exactly. But generative AI, particularly during the inference phase, when a large language model is actually generating a response for you that is fundamentally memory-bound.
Okay, so wait, why is memory suddenly the choke point here? Everyone just talks about the processors.
Well, what's fascinating here is that for AI, that desk you mentioned has to become absolutely enormous. A modern AI model consists of billions, sometimes even trillions, of parameters and weights.
That is just a massive amount of data.
It is. And every single time the model generates a single word or token, it has to pull those billions of weights out of memory, move them into the processor, do the math, and then send the result back.
Oh, wow. So the processor might be the fastest calculator on Earth, but it's spending the majority of its time just like sitting entirely idle.
Right. It's just waiting for the data to physically travel from the memory banks.
I see. So it's like, if you think about standard computer architecture, you have the memory acting as this massive reservoir of water, and the processor is the turbine.
Yes, perfect analogy.
And standard memory bandwidth is basically like connecting that massive reservoir to a hyper-advanced turbine using like a standard garden hose.
Right. You can spin the turbine all you want, but you just aren't getting enough water through the pipe to actually generate power.
That makes total sense.
And that structural limitation is what the industry actually calls the memory wall. To tear down that wall, hardware engineers developed high bandwidth memory, or HBM.
Okay, HBM, I've seen that acronym thrown around a lot.
Yeah, and it changes the plumbing entirely. So instead of just trying to run a wider hose, they are literally stacking layers of ultra-fast memory chips on top of each other.
Wow, like a skyscraper of chips.
Exactly, up to 12 or 16 layers deep. And then they place that entire stacked reservoir directly adjacent to the processor on the exact same piece of silicon.
So it's basically a Formula One car stuck behind a toll booth, right? The car has all the power in the world, but it can't use it until you widen the toll booth.
That is exactly it. HBM drastically shortens the physical distance the data has to travel, which just exponentially increases the throughput.
But producing that layered HBM is incredibly resource intensive, isn't it?
Oh, incredibly. The stacking process is so complex.
So here's what I'm trying to reconcile, though. How does an AI data center buying this super premium specialized HBM affect the standard DDR memory going into my basic consumer laptop? Because they aren't the same components, right?
No, they aren't, but they share the exact same foundational silicon wafers and the exact same manufacturing capacity.
Ah, okay. So it's a zero-sum gain on the factory floor.
Exactly. When a company like Micron or SK Hynix shifts their fabrication lines to produce more HBM to meet this explosive AI demand, they are actively pulling raw silicon and line time away from standard consumer DRAM.
Wow. So they just make less of the cheap stuff.
Right. And the yield rates for HBM are also a lot lower because the process is so difficult, so it consumes vastly more raw wafers just to produce the same gigabyte capacity.
Man, that is brutal for the supply chain.
It is. And furthermore, an AI data center isn't just GPUs and HBM. To feed data into those processors, the facility requires massive amounts of conventional server memory and enterprise storage just to run the whole building.
Which brings us to the actual buying behavior driving all of this, right? Let's use a hotel analogy.
Okay, I like where this is going.
So if the global memory market is a hotel, AI companies are essentially the ultra-wealthy VIP guests renting out entire floors years in advance.
Yes, that is spot on.
So what happens to the regular traveler, the consumer tech companies who are just trying to book a standard room for the night?
Well, they're out of luck. Memory makers are seeing this massive committed demand from the VIPs, and they're prioritizing those high-paying cloud companies.
Because they're the ones writing the giant checks.
Exactly. Just to give you the hard numbers, Micron recently disclosed they have $22 billion in supply commitments locked in from just 16 strategic customers.
Wait, really? $22 billion from only 16 clients?
Yes.
That is insane. That tells me this isn't just some speculative bubble. Those cloud providers are genuinely terrified of running out of memory.
Well, they absolutely are. They are buying future capacity before the silicon is even melted down. And to take that a step further, look at the mechanisms they are using to secure it.
What are they doing?
They're utilizing take-or-pay structures. These aren't just, informal pre-orders or handshakes.
So they have to pay no matter what.
Right. They are binding financial contracts where the tech giant pays whether they actually take delivery of the chips or not. They're just guaranteeing the manufacturer's revenue for years just to hold their spot in line.
Wow. And that drives up prices for everyone else.
Oh, drastically. TrendForce projected that conventional DRAM contract prices could rise between 58 and 63% by the second quarter of 2026.
That is huge.
And NAND flash, the silicon used for storage, is looking at a 70 to 75% increase. The consumer market isn't entirely abandoned, but it's being crowded out at the margin, and the margin is where prices are set.
Let me push back on the scale of this for a second, though, playing devil's advocate. I get that data centers are huge, but consumer tech companies sell hundreds of millions of phones every year. Apple alone sells over 200 million iPhones.
Sure, the volume of devices is massive.
Right. So are a few dozen hyperscale data centers really buying enough raw silicon to crowd out a market of 1 billion smartphones?
It sounds super counterintuitive, but yes. A standard smartphone might use like 8 gigabytes of RAM, but a single AI server rack can utilize terabytes of memory.
Yeah, wow.
And a single new data center project deploys thousands of those racks. So the aggregated raw bit demand from the cloud sector is just fundamentally restructuring the whole market.
So they just dwarf the phone market in terms of raw gigabytes.
Exactly. Plus, consumer electronics are notorious for razor-thin margins. AI infrastructure has near infinite price elasticity right now because of multi-trillion-dollar valuations.
Let me keep playing devil's advocate here.
Yeah.
If my premium phone or my $1,200 laptop costs a bit more, it's annoying, but companies can offer financing or bundle in some software is really a crisis.
Well, if we connect this to the bigger picture, the hidden danger isn't with the flagship devices. A $1,200 laptop has wiggle room, but a $150 budget phone has absolutely zero margin for error.
Oh, I see.
So chipflation won't necessarily look like a giant price increase. Everywhere it will look like disappearance.
Disappearance.
Yeah.
Like they just stop making them.
Exactly. Low-end models lose storage, cheap configurations completely vanish from the market, and companies just stop making thin margin budget tech entirely because the bill of materials is suddenly higher than the retail price.
Wow. So the 256 gigabyte option on the cheap tier just goes away. You're forced to buy the more expensive one?
Yep. Or you get pushed to the refurbished market.
And that creates a massive societal impact.
Yeah.
Right? Because for a well-off professional, paying more is just an annoyance. But for a student, a public school district, or a small business.
Right. It creates a widening digital access gap. This delay in affordable hardware means delayed access to modern education tools, remote healthcare, and basic banking.
It essentially prices people out of the digital economy.
It does. But the impact isn't just on individual consumers. We also have to look at the corporate impact, which is just as disruptive.
Right, because we tend to treat the cloud like it's magic.
Yeah.
You just see a clean login screen, but there's a heavy industrial reality behind it.
Exactly. And that brings up the second and third order effects here. The biggest one is corporate budget cannibalization.
Meaning what, exactly?
Well, businesses are spending huge money securing AI servers right now, which means they have way less capital for standard IT.
Oh, so they're putting off the boring stuff.
Exactly. They delay basic software upgrades, or worse, they defer critical investments in cybersecurity infrastructure because all their money is tied up in the AI arms race.
That sounds like a recipe for a disaster.
It really is. And here is a major pattern interrupt to think about that free AI model you might be using in your browser right now.
Yeah, the one generating images or writing emails for me.
Right. It is only free because someone else, a massive corporation, is paying a memory bill that keeps rising every single day.
Because it's consuming significant compute and memory every time I hit enter.
Yes. And eventually, cloud providers will have to absorb those costs. They'll have to tighten their limits, degrade the free tier, or just favor massive enterprise clients. The era of free, infinite digital tools is built on cheap hardware, and that foundation is cracking.
Okay, so demand is through the roof. The foundation is cracking. Capitalism 101 says we just build more factories, right? The software world moves at the speed of light. Why is there a global choke point? Just build more fabs.
Well, this raises an important question about the harsh reality of semiconductor manufacturing. You simply cannot code a new memory fab into existence.
So you can't just throw $50 billion at it and have a factory next month.
Not even close. Memory fabrication requires extreme ultraviolet lithography machines, EUV. They are made by exactly one company in the world.
Oh, wow. Just one company.
Yes, and they take years to build. Plus, you need advanced packaging, volatile chemicals, and a highly geographically concentrated supply chain. It is atomic-level precision.
So the physical supply chain is just fundamentally slower than the software world.
Exactly. Even if you break ground on a fab today, it takes years of construction and agonizing qualification cycles before you yield a single usable chip.
Which creates a vicious feedback loop, doesn't it?
It really does. Large cloud companies fear scarcity, so they pre-order. Then the suppliers prioritize them.
And then the smaller buyers see that, they panic, and they start ordering earlier, too.
Yes. The queue just grows and grows because everyone is trying to avoid the queue. It is completely rational behavior, but it drives extreme scarcity.
Okay, here's where it gets really interesting, though. Because there is a theory out there, won't AI just get more efficient over time?
Ah, yes. The bull case.
Right. If the models get smarter and the engineers compress them to be smaller, will they use way less memory and basically solve the problem entirely?
That is the big debate. The bull case says, yes, high prices attract investment, memory makers expand, software gets vastly more efficient, and supply eventually catches up. So chipflation just becomes a temporary growing pain?
Okay, that sounds pretty optimistic. But what's the bear case?
The bear case introduces the efficiency paradox. It's essentially the Jevons paradox applied to AI.
The idea that making something more efficient actually increases total demand.
Exactly. If AI gets significantly more efficient and cheaper to run, we don't just use it the same amount. It becomes so useful that it leads to exponentially more use cases.
Oh, I see. So the toll booth gets faster, but the highway just fills up with millions of more cars.
That is a perfect way to look at it. We stop querying a chatbot once a day, and we move to continuous inference. AI gets integrated into every search, every video, every piece of code, operating 24/7 in the background.
So the efficiency gains get totally swallowed by the sheer volume of new activity.
Exactly. In fact, Micron has explicitly warned that these tight conditions could persist well beyond 2027 because new inference uses are spreading much faster than fab capacity can grow.
Wow. So bringing this all together for today's analysis, we are looking at a massive paradigm shift. For 3 decades, consumer electronics, the phones and laptops you and I buy, they dictated semiconductor manufacturing.
They absolutely did. They were the undisputed drivers of the market.
But that era is effectively over. Now, data centers are the absolute kings of the market. Your handheld device is competing directly with global, multi-trillion-dollar AI infrastructure for the exact same physical resources.
The assumption that hardware will perpetually get cheaper has been completely upended by this.
So the next time you see a price bump on a basic piece of tech,
Right.
or you notice the storage size is shrinking, you'll know exactly what's happening. It's not just a consumer electronics story anymore about a company padding margins. It's an AI infrastructure story.
It really is, and I think that leaves us with an incredibly provocative thought to consider.
What's that?
Well, given that memory now dictates the price, availability, and scale of global artificial intelligence, should these memory chips still be treated as just ordinary commercial commodities? Or has AI just turned them into strategic national infrastructure that countries must secure, exactly like energy, critical minerals, and the power grid?